Good morning, this is Mrs. Marquette. Today I'm going to do some Chapter 9 review. So I'm going to look at your review worksheet and I think I'll just work through the evens. That's about 7 problems. So starting with number 2, I have two fractions multiplied by each other. So my goal when I'm multiplying, so I've got this multiplication sign in the middle, is I want to factor and then cancel everything that I can. So I want to simplify the end product. So what I'm going to do first is I'm going to factor absolutely everything. So that's going to mean p squared plus 2p minus 24. I'll have 2p's. I need to add to 2 multiply to 24. So that'll be negative 6. Actually, it'll be positive 6 and negative 4. So that I can get to a positive 2. And then on the bottom, I actually only have p minus 4. If it was a p squared minus 4, then I could factor, but p minus 4 I just leave. Then I can put it in parentheses. Then I've got 1 over p squared minus 6p plus 8. That will be p minus 4 and p minus 2. So that multiplies to 8 and adds to negative 6. So now I can look, and really when you have two fractions, you can write this just as one big fraction. So as long as there's one factor in the numerator and one factor in the denominator, they'll divide up to 1. So p minus 4 and p minus 4, I could do that p minus 4, or I could do one in the same fraction. It really doesn't matter. And that's really all that cancels. So in the end, I get p plus 6 times 1 over p minus 4, p minus 2. And I would really leave it like that. Like you could FOIL out the denominator, but it's nice to kind of see all those pieces, and it's less work to just leave it in that simplified form. Number 4 is very similar. I still want to do some canceling. What you can't do is you can't just start canceling. All right, what I want to do actually is factor. So I'm going to factor out a GCF in the numerator. I have r times r minus 2. Then on the bottom I have r cubed. Okay, now I can go to battle. I've got on the top r to the first, and on the bottom I have r to the third. Since this is multiplication, I can say, all right, the bottom is going to win by 2, and that is all I can cancel. So my answer is r minus 2 over r squared. Okay, so anytime you see these problems, you have to factor. Once you start factoring, I think you'll be like triggered on your memories, what can cancel and what needs to stay. Number 6, the main thing is that this is division. So remember that when you have, how do you divide by a fraction? You multiply by the reciprocal. So I leave the first fraction just as it is, and then I multiply by the reciprocal of the second. So I get 45x squared over 3y times 1 over 2x. So this changes to be a multiplication sign. Then I can multiply across the top, multiply across the bottom. So I get 45x squared over 6xy. And then I need to go to battle, so don't forget to do that. My 45 and 6, those can both divide by 3. So I would get 15 and 2. And then if I go to battle with my x's, actually, we'll just make a new fraction. So 15 and 2 for our numbers. For x's, the top is going to win by 1x, and on the bottom I just have y. So final answer, 15x over 2y, and that is as simplified as I can. Notice that I can just cancel without factoring here because everything is already multiplying. Okay, I don't have any pluses or minuses, so it's okay to do all of that canceling. Number 8, here is a different type of problem. We're adding. When you're adding, you absolutely need an LCD. So this is when you can't just start canceling or doing anything like that. You've got to say, okay, the LCD is going to need a 2 and an x. So what is the first denominator missing? It's missing an x, so I need another x in the top and bottom. And then the second one is missing a 2 and a 2. So the first, I'll have 3x cubed over 2x plus 10 over 2x. Now I have an LCD. I can keep the denominator, 2x, and add the numerator, so 3x cubed plus 10. Notice that that didn't become 13x cubed. That's just adding, so they're not like terms, so I just leave it as it is. So LCDs, very, very important. Write down your LCD first, and then make your denominators look like the original LCD. Number 10 is similar. What I want you to remember is that negative. So first I'm going to find our LCD, but then I'm going to be careful when I use it. So our LCD is going to have a 4, an x minus 2, and then this x is different than the x minus 2, so we have to include that as well. Okay, so the first is going to need an x and an x. The second needs the 4 and the x minus 2. Right, so then I'll get 3x over 4x, x minus 2. And then really what I'm going to have is plus a negative. 2 times 4 is 8, x minus 2 over 4x, x minus 2. Okay, we'll combine our fractions. I get 4x, x minus 2, and then 3x, and then I'll distribute that 8. So I get negative 8x plus 16. Okay, and now I can combine like terms. 3x minus 8x is negative 5x plus 16 over 4x, x minus 2. So again, it's a little bigger of a denominator rather than this one, which is just 2x, but we're doing the same thing. We're finding our LCD, we're writing our fractions to have that LCD, and then we are simplifying when we are all done. This time, we had to remember the negative. Number 12, this is now solving, and specifically solving by the LCD, numbers 11 and 12. So again, I'm going to need, what is that LCD? Okay, the LCD here is x minus 2. You don't need x minus 2 squared because they both already have 1. What I do need is I need 8 to have that LCD. So I put x minus 2, x minus 2. Okay. Now my denominators already match, so really all I need to do is say that 3x is equal to 8 x minus 2 plus 9. And now this is a pretty simple equation. Now that I've gotten the LCD there, I get 3x equals 8x minus 16 plus 9, and I can solve, right? So I can subtract 8x on both sides. I get negative 5x is equal to negative 16 and 9 is negative 7. Divide by negative 5. So x is 7 over 5. Or you are welcome to change that into a decimal, but I would leave it just as 7 over 5. Okay, so this is kind of the same skill as number 10, finding your LCD. The difference is here, when we're just adding or subtracting, we keep the denominator. When we're not adding, when we're solving, since we have an equation, we're just looking to make the numerator equal. So you keep that equal sign, but you can lose the denominator. And the last two are cross multiplying. So this is where I set up my cross multiplying. I do 2 times x minus 2. The biggest thing that I see is that you guys want to make this a fraction. Instead, since this is an equal sign, set this up as an equal sign. So then 1 times x squared minus 2x. So this is going to look like is 2x minus 4 equals x squared minus 2x. If you want to solve this, what we notice is that we've got a squared. Okay, when you have a squared, you know that you're going to factor. So we want to get everything on the same side and add multiply. All right, so I subtract 2x and add 4. I get 0 equals x squared minus 4x plus 4. And then factoring add multiply, this actually works out pretty nicely. I get x and x, negative 2 and negative 2. So then really I get x equals, x equals 2 and x equals 2 for my solution. All right, we don't really need to write it twice, okay? Since it's a repeat, we can just give 1. But then don't forget to look back at your problem and see, is this an okay answer? X minus 2, if I plug it in, actually is going to make this denominator 0, since 2 minus 2 is equal to 0. So this is a bad answer. This is called an extraneous solution. Or if you just give me EXTSOL, that's okay with me. So just EXTSOL. That'll tell me that you know that it's extraneous solution. So doing the actual solving tells us, like, if we could have this as a solution, x equals 2 would be it, but it doesn't actually work for us. It's an extraneous solution. So those are the types of problems that you'll be seeing on your test. It's just factor, simplify, or find the LCD and simplify or do your solving. So do the rest of these problems for sure. There are also more practice problems on Blackboard. There are tons of worksheets. So do your practice and then come see me if you have any questions. Bye, guys.